Phospholipids contain a head group, choline in this case, that is attached via phosphate group to a 3-carbon glycerol backbone. 2 fatty acid tails are attached to the remaining 2 carbons of the glycerol. The head groups and the phosphate are polar, that is, they prefer to be in an aqueous environment. In contrast, the fatty acid tails are hydrophobic, that is, they are repelled from water. The fatty acid tails on phospholipids can be saturated with no double bonds or unsaturated with 1 or more double bonds. The double bonds are usually in the cis configuration, which introduces sharp kinks. When forming a bilayer, unsaturated fatty acid tails pack loosely, which allows the bilayer to remain fluid. If there were no double bonds, bilayers would solidify to a consistency resembling bacon grease. Cholesterol is another lipid component of most cell membranes. It has a hydroxyl group, a tiny polar head group, so to speak, attached to a rigid hydrophobic tail. Cholesterol can fill gaps between phospholipids and thus stabilizes the bilayer. In a lipid bilayer, lipids arrange themselves so that their polar head groups are exposed to water and their hydrophobic tails are sandwiched in the middle.